Hey everyone, it's Miss Lloyd, and today we are looking at properties of logarithms. So here with our logarithms, say we want to break some of them up into some lighter pieces or push them or smush them all together so we only have one thing to plug into our calculators. There are a few different ways to look at it. So if two things are multiplying inside of our log, like this, then we can separate them into their own logs, and those logs will be adding together. And this goes both directions. So say you have two logs that are adding together and they have the same base. That is a very, very important part. They have to have that base the same. Then we can smush them together into one log with that same base. And those two things that we were taking the log of would be multiplying together. When it comes to division, then they'll be subtracting on the outside. Again, these bases have to be the same in order for this to work out, and it still goes in both directions. So if we have two logs that are subtracting and we want them into one log, then the m and the n, the things that we're taking the logs of, will be dividing, and the order is important. So whatever's in the numerator is going to go first, whatever's in the denominator is going to be what's being subtracted. And then same thing when you push it back. And then lastly, when we have a exponent there on the inside, then we would be multiplying it outside of the log. Those are going to be equivalent to each other. We also have a change of base formula. So this is something that I use if I'm using the calculator on my phone, or if I am using a calculator that doesn't have the nice function where you can change the base. So this changes it so that we have basically log base 10. And so my phone calculator and some of the very basic calculators don't have a log button that you can use for anything. It only has a log base of 10. So if we're doing a log base of 10, this is going to be equivalent. So if I have log of some base A of B, then we'll have log base 10 of B divided by log base 10 of A. And these two are going to be equal to each other. So it's a way to figure that out if we can't necessarily plug it into our calculators. So here for the first one, they want us to express this in terms of log base 10 of A and log base 10 of B. So they want me to separate this out. One of the first things I notice is that I have my A and B in here multiplying together. And so again, maybe I should clarify, when they say log base 10 of A and log base 10 of B, that means that they don't want anything inside of the log aside from just A and B. So here we have A and B together. We don't want them together, we want them separate. So in order to separate them, because those are multiplying, I can separate them into their own logs and they're going to be adding together. We also have issues with this square that's on the inside and the square root b. So first off, the square root b, we don't have anything in our log rules about square roots, but we do have stuff about exponents. So I'm going to change my square root b into an exponent, which the exponent for this is going to be 1/2. Anytime we have a square root, it's the same as having an exponent to a half. And so because these have exponents, then our log properties say that these can be multiplying on the outside. So then my A and B are completely alone inside of the logs. So now we have officially expressed this in terms of log base 10 of A and log base 10 of B. So inside those logs are only the A and only the B. It's fine if we have stuff on the outside. This is how we would express it. So most of the time they're going to give you something to where you know what log base 10 of A is. Maybe it's log base 10 of 7 or log base 10 of 2, but they give you that actual number. So this is something that you can see in SATs or ACTs where they want to see if you can break this stuff up and use their decimals that they give you maybe on a non-calculator portion of an exam. So here we're going to do the same thing, just now we have C and D. Again, these two things are multiplying inside together, and I don't want them inside together, I want them separate. So when I separate these two, they'll be adding together. I also just want C and D alone inside the logs, so I need to get rid of these exponents. Because they're exponents on the inside, it means they're going to be multiplying on the outside. And so the only thing inside my logs now are C and D, and they are in their own separate logs, so that is as far as I need to go. So here's what I kind of warned you guys about. They've given us log base 4 of 10 is equal to 0.6, and log base 10 of 4, and log base 10 of 3 is 0.48. So what they want us to do here is now break up this 36 into terms of 4 and 3. So something that I know about the number 36, I know I can take a 4 out of 36. When I take a 4 out, I would be left with 9. And I know I can express 9 as 3 squared. So instead of writing 36, I'm going to be writing 4 times my 3 squared. This is equivalent to 36. If I were to plug 4 times 3 squared into my calculator, 3 squared is 9, 4 times 9 is 36. So I'm just replacing this 36, and I'm using 4 and 3 because that's what they gave me to begin with. I know log in terms of 4 and 3, so I want to break things up into 4 and 3. And I only know log base 10 of 4 and log base 10 of 3, which means I need to separate some things. I see that I have multiplication there on the inside, so I can give these both their own logarithms, and those are going to be adding together. So my log base 10 of 4 is all done out. I can always replace that with the 0.60 that they gave me above in my directions. However, they didn't give me log base 10 of 3 squared, they just gave me log base 10 of 3. So this squared needs to be multiplying here on the outside. Now that I have my log base 10 of 3, I can replace it with what they told me that was equivalent to. And when I plug all this stuff in or do all of my multiplication and then the addition, I end up with 1.56. Next, we've practiced breaking up these logarithms, and now we're going to start smushing them together. So for this first bit, I don't want anything outside of my logarithms. So I see this 1/2 that I have multiplying in the front, and I know that because it's multiplying in the front, that means it should have been an exponent on the inside. I also know that 1/2 exponent is the same as a square root, so I can always replace that as well. Now I can start looking at, I have subtraction here, so that means these two logarithms, when I smush them together, the square root 4 and the 2 are going to be dividing on the inside of their own logarithm. Square root 4 showed up first, so it gets to go on top in the numerator, and the 2 came afterwards, so it's going to go in the denominator. And we do this in order of left to right. So I start combining from left to right whenever I'm looking through these. Also, I know the square root of 4 is 2, and then 2 over 2 is going to just give me 1. So then my last step is to combine these last two. They're adding together, which means my 1 and my 8 are going to be multiplying inside of the log together. And 1 times 8 is just going to give me 8, so my single logarithm is a natural log of 8. And we're done. The last one, they want us to evaluate using the change of base formula. I always like to add that as to if your calculator doesn't do like change the base for you or give you an option to change the base. And then they want us to round to the nearest hundredth. So if I'm using my phone calculator, because sometimes I don't have my genuine calculator, my TI on me, then I would have to do log 12 over log of 2. Again, because my calculator doesn't have a log base 2, it just has a genuine log, which is technically a log base of 10. So when we plug this in, you can always pause to plug it in and then check your answer with mine to make sure that you know that you're plugging it in correctly. And it would give us a 3.585. Although it does say to the nearest hundredth, and so that's the second number after the decimal, so I'm going to have to round that to a 9. And that's all that I have for you guys today. The rest of these are going to be for my students in class. We can work on some of these together. If you enjoyed this or you thought it was helpful, please like and subscribe. If you think that someone else could use this, you think it could be helpful for them, please feel free to share. Spread the love.